Hello everyone, myself Ashit Desai, Assistant Professor, Institute of Technology, College of Engineering. Today we are going to discuss the cooperative and swarm robots. So now we know that about cooperative and swarm robots. So cooperative robots which involves the communication, sharing information and coordinating movements to complete the task efficiently. So here the robots are in a cooperative manner. So everyone can be engaged with their activity, and after the coordinating, the task will be performed. So example in an industrial setting that can be optimize the production by handling the specific task on an assembly line. So best example of the assembly line which is working with the cooperative robots. But in case of swarm robots, so here the behavior of the swarm robots, which is rely on a that we can concept of a inspired from the insects. So this mimic natural swarm behaviors. It is like a decentralized control, and it is exhibit to collective intelligence. They can adapt dynamically to the environments, and it is application like rescue or can say search applications. So example is drone. So it is exploration for the search and rescue operation. So individually that can be work, and that is about the swarm robots. Okay, so this is about the environment, which is about the multi robots are there, but it is working in a that achieve the common goal, that is by using this cooperative robots and swarm robots. So we are differentiated in the cooperative robots. So the moments and the information is sharing is possible in a cooperative robots, but in swarm robots the behavior is a decentralized manner. So it is not happening with a uh, not every with that environment. So it is adapt to the dynamically change, and then it can be performed. So every time the task is same, but the nature or environment is different. So it is for the working style is the swarm robots. So this is the fundamental technologies for the multi-robot system. So firstly, we are see in a pyramid manner, that is self reconfigurable robot, so which is a physical connection with among the robots. This is the present. The application is for the rescue and exploration. So this is self reconfiguration robot work on same task. So collaborative robot is there. So it is functionized in a same manner, and it is applicable in a production or you can say surgery type of work. Then next is about share workspace and information. So here multi-robot system is there. So it is useful for in a logistics manner or you can say in transportation manner. So one-to-one task is allocation is there, and after the performance, the work is carried over there. So this is about the fundamental technologies for the multi-robot system. So this is the shows in a pyramidal manner. So self-configurable in a rescue type, we can say drones are used over there, and in collaborative robots, so in a surgery type of assistive work is there. So this is on same task we are performing over there, that is about collaborative robots. So this is a kind of action for the multi-robot system. So we discussed the first is about cooperative robots. So robots that can collaborate, communicate, and coordinate to the perform tasks efficiently. So this is the uh, seeing in a that robots that is in a cooperative robots or cooperative robots. The key feature is about centralized or decentralized control. So maximize the centralized control are available. Then the work is about the task allocation and synchronization manner. It can perform the task. So application is industry automation. Example is assembly lines. The multi-robot exploration and mapping is possible. So this is kind of action we are doing with cooperative robot. Then medical and assistive robots. So here the medical sectors and assistive robotics which are present over here, that is the cooperative robots nowadays. Now we are differentiating with swarm robots. So it is a large group of simple robots work together, but decentralized control is present for the swarm robot. So main differentiate is the decentralized control is present in a swarm robots. Performance for the work is same, but decentralized control is present over here. The key feature is scalability and redundancy. The next is about simple local interactions, so which is lead to the complex collaborative behavior. Then next is about application, that is which is finding in a environmental monitoring, search and rescue missions, and precision agriculture. So this is about the swarm robot. So nowadays we are finding the agriculture for the spraying of the fertilizers and about the harvesting. So we are doing with the swarm robots. So now we are differentiated with the easiest way, that is in a cooperative versus swarm robots. So as per the feature of controlled structure, that is cooperative robots may be centralized or decentralized. In swarm robots, it is fully decentralized. So the action can be done or the decision may be done with that system only. It is not depending on the other systems over here in a swarm robots. The communication is direct coordination, and some robots in a local rule based is there. So here there is the locally we can operate this robots. Then task handling, so task sharing and synchronizations is possible in cooperative robot. Some robots is about emergent behavior, so emergent behavior is in a some robots. Then application scale, so small to medium groups, that is about cooperative robot. Then next is about large scale deployment. So the swarm robots is deployed in a large scale areas, but in case of cooperative robots, is it present in a small to medium groups. So these are the differentiated areas about cooperative versus swarm robots. Now we are going to discuss the cooperative manipulation. So cooperative manipulation, that is the involves multiple robots working together and handling their objects or the perform or task in a required coordinations. So here by synchronizing the moments and sharing the information is possible, and that is maybe capable for the heavy object efficiently or complexly it can be perform their works. So example we are discussing here, that is cooperative manipulation. So here the human is standing in front of that robots, and this image we can human robot cooperative manipulation system, where the robotic arm that is about assisted to the human using EMG sensor, that is helpful for the operating the muscle activity. So whenever the movement is possible by doing by the human being, same action by doing over there, and this requires to be hybrid force impedance controller, which is take the feedback from the myoelectric sensors, and this base the task interfaces with this and conditionizing the synchronized motions, and adaptive forces will be applicable, and then the performance will be possible. So this system enables to the precision collaborations for the application in industry assembly, rehabilitation, and assistive type of work. So here the image dissipates the task frame feedback interface, that is by using mild trick feedback interface. Then hybrid type of control is there, and the force feedback it can be calculated against the soft hand or with the optical maker. So this is about the cooperative manipulation which is available with the system, so which is the cooperative manipulations. Then next we are reviewing on the multi-robot system in agricultures. So nowadays we are the agriculture robots which is fascinated with the different platforms, that is about ground vehicle type, aerial vehicle type, mobile manipulator type, and multi-robot type. So these are the platforms we are using for the agriculture purpose. Also we are having the different control levels are there, that is low level control, localization and mapping, that is passive collaboration, active collaboration. So this is type of agriculture robots also available with us, and different applications we are doing with this activity or this is platform with the different control systems. So which is possible for the mapping and sensing, then crop management, then soil management, also possible the spraying and harvesting. So that is about multi-robot system in agriculture. So main discussion is in the trends and challenges. So basically the trends are nowadays in a large scale agriculture system is there. So at that time the agriculture robots is used in a commercial manner. Also we are having the cooperative manipulation is also possible in agriculture areas. Then future application is different ways. We have wheel robots and aerial type of vehicles. We can arrange different tasks with that robot. So this is the possibility with a multi-robot system in agriculture. So now we are going to discuss the challenges which is faced in a cooperative manipulation, that is about communication and coordinations. Because of the synchronizing moments, so there is taking the real time data is making more problems. So there is not effective manner which is completion of your works, that is about communication and coordination. This is lagging behind here. Same way we are uncertainty and variability is there, so that is handling unpredictable environment and object variations and external disturbance also created over there. So that is also main challenge for the cooperative manipulation. The next is that is about control complexity, that is designing the adaptive control algorithm. So getting the that precise force and motion control coordination is possible in a control complexity. The next is about human robot interactions, so that is ensuring the that is safe and efficient collaboration in shared workplace, that is about human robot collaborations or interactions is possible. The next is about sensing and feedback, that is accurate perception using sensors for the object and the detections for estimation and motion tracking. So this is also making problem because the different sensors is that much capability is required. Also, it providing the feedback to the system. So this is the main challenge with us. The next is about computation load. So this is more computing power is required for taking the real-time decisions. So this is more required computation power and the so that execution is possible. So that is why the challenges is facing in a collaborative or cooperative manipulations. The next is about the energy efficiency. So there is power should be consuming more, so it is prolonged operations. So it is more challengeable in the point. So this is about the challenges which is faced in a that robot system. So now we are going to discuss the case study which is reliable in a collaborative robots. So which is if we utilize in a automotive assembly. So this is the case study we are going to discuss over here. So now we are going to discuss the cooperative robot, that is cobots. So which is in a assemblyman lines. So which will improve the efficiency, precision, and worker safety also. Because the cobots we are having the different sensing ability and which is manageable for the any type of accident. So we are having that type of capability we are providing for the cobots. So implementation type of the cobots in a that automotive assembly which is works with a worker having with work in a different task like welding, painting, and the component assembly. So here also we are driven by the AI system, so which is real-time adjustments and safe human robot interactions is possible. That is about implementation levels. Also we are providing with the vision system, so which is useful for the quality control and detection of defects. So this is also possible, which is in implementation levels, so which results with up to 30% increase in the production efficiency. Also we are reducing the work fatigue in a also in injury risk will be less. So that is about the collaborative robots. The results will be here in leading to the fewer defects and a rework is possible. So that is why the collaborative robots, the optimized option is possible and improving the productivity and safety. So this is high quality standards we are providing in a automotive industry. So there's mostly collaborative robots we are using in this automotive assembly lines. So these are the area we are going to discuss. So this is about the collaborative robots. So in this content we are discussing the SOM robots, then collaborative robots, then challenges which is faced in a collaborative robots. Also we are discussing the review on the concept of multi-robot system, that is in the case of agriculture robots. Also we are discussing the case study on collaborative robots which is enhancing the automotive assembly lines. So these are the content we are discussed in this content. Thank you.